guys, we're going to dive right in here to chapter 5.1, operations of polynomials, and our goal today is to be able to simplify expressions. And when I talk about simplifying expressions, what I mean is getting rid of parentheses and getting rid of negative exponents. And that's just super important to make sure that when we're simplifying expressions that it's easier for us to do and we can see the relationship between different numbers and different exponents. But here, so I have these rules just to keep in mind. You don't have to memorize them, but you will need to be familiar with how to handle them when you see them in a problem that I give you. But some of these rules you've already seen before, you've just never seen it in this defined form. So I'm just going to walk through each of these one by one and give you an example, and then we'll start down here with actually applying these rules. But the first one, product of powers, okay? What we're talking about here is when we take two numbers with the same base, okay? So in this case, x times x, right? This first x is x to the power of a, and the second x is x to the power of b, and I'm multiplying them. When you have this, so when you have two numbers with exponents with the same base and you're multiplying them together, what you're doing is you add the exponents, okay? So an example of this would be 3 squared times 3 to the 4th, okay? Notice they have the same base number, 3, okay, and they both have exponents. So, since what I talked about here, I'm adding exponents, I get 3 to the power of 2 plus 4, or just 3 to the 6th power, okay? That's a rule that we've used before, okay? That shouldn't be too new to you, but this form, this defined form, is probably new to you, so don't let this confuse you, but you have seen this math before. The next one, quotient of powers. Quotient, okay, we're talking about division here. Product up above was multiplication. Quotient of powers is when this rule applies to when we have two numbers of the same base and we're dividing them, okay? When we divide two numbers with the same base with exponents, what you're actually doing is just subtracting the exponents, all right? So, in this definition, x to the power of a divided by x to the power of b equals x to the power of a minus b, all right? So an example of this would be 9 to the 5th power being divided by 9 squared, okay? If I look over here, I know I need to subtract the exponents. So this just becomes 9 to the power of 5 minus 2, which is 9 to the 3rd power, okay? So think like over here, product, okay, we added. So multiplication and addition goes together. Quotient, okay, we're dividing. Division goes with subtraction, okay? So keep those two things in mind. Negative exponents, okay, so this, just think inverse here. Okay, think inverse. Because if you have a base number to the power of a negative exponent, you can just rewrite that as 1 over that number to get rid of that negative. Notice the negative a turns to a positive a once I move to the bottom, okay? Or another way to look at this, if you have a negative exponent that's already in the denominator, okay, just bring it up to the top, okay, like this example, 1 over x to the power of negative a equals, if I bring it up to the top, x to the power of positive a. Okay, so these two relations right here, they're just inverses. So if you have a negative exponent, whether that's in the top or the bottom, switch it to the opposite side, and that exponent will become positive, which is our goal here. So an example of this, so say I have 3 to the power of negative 5, okay? I can make that 5 positive by putting that 3 to the 5th power on the bottom, okay? Or what if I have 1 over b to the negative 7? So now the negative exponent's in the bottom. I can just make that positive by flipping that, and bringing the b to the negative 7 up to the top to be b to the positive 7. Okay, our next rule, power to a power, power of a power, is when we have a base number with an exponent being applied to that. So here we have x to the power of a to the power of b, okay? And all you're doing here is you multiply the exponents together, all right? So an example of this would be 3 to the 3rd power squared, okay? Since I have an exponent with an exponent, okay, I'm just gonna multiply those two. So 3 to the 3 times 2 which is just 3 to the 6th power. Okay. All right, our next one, power of a product. So here, the product is going on inside the parentheses, x times a, that's product, okay? Then I have an exponent being applied to that. When you have this scenario, okay, that exponent gets applied to both parts. So this a goes to both the x and the y. So x times y to the power of a equals x to the a, y to the a, right? An example of this is 2k to the power of 4. When I have something like this 4 gets applied to both parts. So this becomes 2 to the 4th times k to the 4th, or just 16k to the 4th. Okay? All right, 2 more. Power of a quotient. Sorry. Product up above, we were talking about multiplication. Quotient now, we're back to division. Okay? Here, same idea when we were distributing the exponent to both parts, but now we're using division. Okay? So for example, say we have x divided by y all to the power of a. Well, just like before, that a gets applied to both parts. So now I have x to the power of a divided by, this should be a y, sorry, y to the power of b. Okay? Or, say I have x over y to the power of negative a. Remember, negative means inverse, right? So to get rid of this negative a, I'm going to flip this fraction upside down. So now instead of x over y, I have y over x to the power of positive a. Okay, once you're here, distribute to both parts, so you get y over a over x. Y to the power of a over x to the power of a. All right, so some examples of this. We have x over y to the power of 2. Okay, the 2 is positive, so all I need to do is distribute that 2 to both the x and the y. So this becomes x over 2, x to the power of 2 over y to the power of 2. Okay, or another example of the second part of this rule. Pretend I have a over b to the power of negative 2. Okay, this negative means I need to turn this fraction upside down. So this just equals b over a to the power of positive 2. And I'm going to distribute that 2 to both the b and the a. So b squared over a squared. Okay, awesome. All right, last rule, and this is the best rule, the easiest, the 0 power. Basically, anything to the power of 0 is 1. Okay, no ifs, ands, or buts, anything to the 0 power is 1. So, for example, 7 to the 0 power, 1. Okay, 1,000 to the 0 power, 1. Okay, etc. Everything to the 0 power is 1. Okay, so keep these in mind with you. Keep these in mind as we work through the problems and as you go through your homework. So like I said, you don't need to memorize these specifically, but you do need to know how to handle these situations when you come across them. These will help you work through problems. Okay, so if you get stuck, refer to this chart. Okay. All right, so let's go down here to example A. I have a to the negative 3rd times a squared b to the 4th times c to the negative 1. The first thing I notice here are these negative exponents, okay? And I immediately think of these negative exponent rules, okay? So up above here, if I have a negative exponent, all I did to make it positive was put it on the bottom. So that's exactly what I'm going to do over here. I'm going to take a to the negative 3 and c to the negative 1 and put them in the denominator. Okay, so I'm going to leave a squared, b to the 4th on top. And I'm going to put it over a to the negative 3rd and c to the negative 1, but since I'm putting them on the bottom, I can change those exponents to positive. So a to the 3rd, c to the 1st power. Okay. Now from here, I'm going to cancel some things off. So we don't have to do this every time, but I'm going to expand this so that you can see every what exactly that I'm doing. So I have 2 a's on top. So I have a times a, right? Then I also have 4 b's. So times b, 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 b. Okay. Then on the bottom, I have 3 a's and 1 c. So these mean the same thing. This one's just expanded. So here, I'm going to start canceling things off, because if I have the same thing on the top and the bottom, I can just cancel them off, okay? And then I'm able to simplify this expression. So I have 1a on top and 1a on the bottom, cancel those out. 1a on top, 1a on the bottom. Now notice I have no more a's on top, but I still have an a on the bottom, so you have to leave that a, okay? Leave that alone. I don't have b's on both the top and the bottom, so I just have to leave those alone. And then I don't have any c's on the top and the bottom, so I have to leave the c alone. So now to write my simplified version, I just count what I have left. So I have 1, 2, 3, 4 b's left on top, so b to the fourth. And on the bottom, I have an a and a c. Okay, so this is my simplified version. All right, over here. So I have n squared over n to the 10th. Okay, so this goes up to my quotient of powers rule. Okay, so I'm going to be subtracting exponents here. Okay, so what you can think about this, so I have n squared over n to the 10th, and up here it tells me I need to subtract the exponents. So this becomes n squared minus 10, which is n to the negative 8. Okay, now that we have a negative, okay, I can just put that on the bottom to make it positive, which equals 1 over n to the 8th. And that is my simplified version. Okay, another way, if you want to look at this, and in the expanded version, so I have 2 n's on top, okay, and then I have 10 n's on the bottom. So 1, 2, 3, 4, 5, 6, 4, 5, 6, 7, 8, 9, 10. All right, I'm just going to cross off on the top and the bottom until I run out. So 1, 1, 2, 2. I have no more n's on top. Okay, so I have to leave all these leftover n's on the bottom. So since I have nothing left on the top, that becomes a 1, and I have 8 n's left on the bottom, so that's n to the 8th. So you get the same answer both ways. Okay. All right, let's look down here. So with c. So c is going to be looking at this rule, power of a quotient, okay, when we are distributing that exponent to both parts. It's also going to be looking at power of a product, okay, when this exponent is being distributed to something being multiplied, okay? So keep these two things in mind. But the first thing we're going to use is power of products, because I'm going to distribute this 2 to every single part, okay? Now remember, so when I distribute the 2 to the 3, that just becomes 3 squared, okay? But then I'm distributing the 2 to an a cubed. So if I look up here, okay, when I distribute an exponent to an exponent, I need to multiply them, all right? So when I distribute this down here, power of 2 to an a cubed, that just becomes a to the 6th, okay? All over b, so b to 4th with a 2 being distributed to it. 4 times 2 is 8, so b to the 8 on bottom. I just simplify down this 3 squared to be 9, a to the 6th over b to the 8th. Okay, and I can't cancel anything off because I don't have any of similar terms on both the top and the bottom. So this is as simplified as I go. Okay, D is super nice, okay, because we can actually cancel some things off here. So I'm going to do this in 2 ways. I'm going to do it unstretched out, like up here, and then I'm going to do it expanded the second time. So the first time I'm just going to do it without expanding it. So here I'm just going to look at each part. So I'm going to first look at the numbers. So I have a 15 and a negative 3. I know that 3 can go into 15 5 times. Okay, so if I reduce both these numbers by 3, this negative 3 cancels out to just be negative 1, and the 15 becomes a 5. Okay, now let's look at these C's. I have 5 C's on top and 2 C's on the bottom. So if I can and the lowest number I have is 2, right? So that's the biggest number of C's I can cancel off. So I'm going to cancel off this C squared, which means I need to take away 2 C's on top. So this C to the 5th actually just becomes C to the 3rd. Okay. Same idea with these d's. So I have a d cubed and a d to the 7th. So I can only take away 3 d's. Okay, so I'm going to cancel off d3, but then I need to take away 3 d's from this 7. So this set d to the 7th becomes d to the 4th. All right, now I just write what I have left. So I have a negative 1 on the bottom, which I can just write with a negative sign, and then a 5 on top. Then I have a c cubed on top, and that's all I have left on top. Then down here at the bottom, I have this negative 1, which I've already brought down, and a d to the 4th left. All right, so this is my simplified version. Okay, if you want to do the expanded way, all right, I have 15, and I originally had 5 c's. So I have 1, 2, 3, 4, 5. And then I had 3 d's. 1, 2, 3. I'm going to put all of this over, so I had a negative 3, 2 c's, and 7 d's. All right, so now let's just cancel. So 3 and 15 cancel. At 15 becomes a 5. Cancel off my c's, 1 c on the top, 1 c on the bottom, another c on top, another c on the bottom. I have no more c's on the bottom, so I just have to leave these last 3 c's. Now let's move on to our d's. So 1 d on top, 1 d on the bottom, 1 d on top, 1 d on the bottom, last d on top, 1 d on the bottom. So I have to leave all 4 of these other d's because I'm out of d's on top. So now if we just write what I have left, okay, I have a negative 5 on top. And then I have 3 c's left, so c cubed over, and then I have 4 d's. Okay, same answer, 2 different ways to look at it. You're doing the same thing, but this one is it's faster because you don't write out the expanded version, but either way you want to do it is totally fine. Okay? All right, so let's flip over the page. All right, so what I want you to do here is I want you to determine if the expression is a polynomial. And if you say it is, I want you to state the degree. Okay, the degree of the polynomial is a polynomial's degree is the numerical value of the biggest exponent. So let's take notes of that. Let's write that down. So a polynomial degree is the numerical value of the largest exponent. Okay, so a polynomial's degree is the numerical value of the largest exponent. So there are a few rules that talk about what polynomials cannot have. So if you see one of these things in an expression, you know it's not a polynomial. So a polynomial cannot have a negative exponent, okay, square roots, absolute value, or variables in the exponents or denominators. Okay, so if you see these 4 things, it is not a polynomial. So let's look over here on A, B, and C. So if I look at C, okay, and I want you to determine if this is a polynomial. If I look at C, I notice automatically the square root right here, which I know is one of my no-nos. So no, this is not a polynomial, okay? When I look at B, okay, it doesn't have any negative exponents, it doesn't have any square roots, doesn't have any absolute values, and there are no variables in the exponents or denominators. So, yes, this is a polynomial. And now I need to state the degree. And the degree I said was the numerical value of the largest exponent. So let's look over here. Let's find the largest exponent. So I have a 5, a 2, and a 7. So 7 is my degree. We'll just write degree 7. Okay. Last one, C. Okay, I know that this negative exponent is a no-no. Okay, negative exponent. So no, this is not a polynomial. Okay, and again, the degree of the polynomial is the highest exponent. So that's a good note. All right. So You'll have to probably memorize those. So just make sure that you are reading this list and getting familiar with these 4 things that polynomials cannot have. Alrighty guys, hey, just a few more examples, then we're good. So let's look down here. Let's simplify each expression. So A and B are really nice because all you're doing is you're combining like terms, okay? Because we're adding and subtracting. Now with A, we have one additional step because we're subtracting over here and we need to distribute this negative to all 3 parts of this first parenthesis. Okay, so when we do that, this becomes 2a cubed plus 5a minus 7 minus a cubed plus 3a minus 2. Okay, because again, we've distributed this negative sign. So now we just need to combine like terms. And guys, when we're combining like terms, you can only combine numbers with the same exponent. So I can't combine 2a cubed and 5a because they have 2 different exponents. So like terms, in this case, would be 2a cubed and negative a cubed. Okay, they have the same exponent. Okay, so those are what we can combine. So I have a 2a cubed minus 1a cubed. So that just leaves me with 1a cubed. Okay, the next like terms that I have are my a's. So I have 5a, and I can combine that with 3a to give me plus 8a. Okay, then I have a negative 7 minus 2, which is negative 9. Okay, this is my simplified version. Same thing for B, except now I don't have to distribute anything because I'm adding here. Okay, so let's just write it out as one big long sentence. Minus 2x squared minus 5x minus 6. Now let's combine like terms. So I have a 4x squared and a negative 2x squared. So 4x squared minus 2x squared just leaves you with 2x squared. Then I have negative 9x and negative 5x, which leaves you with negative 14x. And then I have a 3 and a negative 6. That leaves me with negative 3. And here's my simplified version. All right, so again, for A and B, you're just combining like terms here. So with A, we had to distribute that negative first, but B, we just went right into combining like terms. Okay, C, okay, so C, we have this negative y outside the parentheses, so we're just going to distribute that to all 3 parts within the parenthesis. So when I distribute a negative y to 4y squared, I get negative 4y cubed, okay? Negative y distributed to 2y is negative 2y squared. And negative y distributed to negative 3 will give me positive 3y. Right? And you are done. Boop. Okay. So that one was just simple distribution. Okay. Here, for D, we're still dealing with distribution here, but now instead of just distributing a single term here, we have a small expression that we are distributing. So what I'm going to do is I'm going to distribute this a plus 2 to all 3 parts of that parenthesis. Okay? Basically, all you're doing here is you're going to expand this parenthesis to leave room to write a plus 2 after each of these terms. Okay? So what I'm going to do, I'm going to have a squared, right? I'm going to distribute a plus 2 to that. So I'm just going to multiply that by a plus 2. Then I'm going to write my plus 3a. I'm distributing the a plus 2 to that, so I'm going to multiply that by a plus 2. Then I'm going to write my negative 4. Distribute the a plus 2 to that. Okay, so we've expanded our first parenthesis, and we've multiplied each term by a plus 2. All right, so now we can distribute within this expanded version. So a squared distributed to a is a cubed. A squared times 2 is positive 2a squared. Okay, here 3a times a is positive 3a squared. 3a times 2 is positive 6a. Negative 4 distributed to a is negative 4a. and negative 4 to 2 is negative 8. Awesome. Now we just combine like terms and we are done. So we don't have any more a cubes, okay? There's no more a cubes within this expression. So we're done with a cubes, okay? My a squareds to combine are right next to each other. So I have a 2a squared plus 3a squared, which is plus 5a squared, okay? Then I have 6a and negative 4a, so I can combine these. 6a minus 4a is 2a. And then this constant's out by its own, so I'm just going to put that on the end. And this is our simplified version. Okay, so again, I distributed the a plus 2 to all 3 parts of this first parenthesis. That's what I did here, so I multiplied all 3 parts by a plus 2. Okay, then I distributed within each section, okay, and then combining like terms to get my final answer. Awesome. Okay, 2 more. Now this one looks nasty, right? But I promise you it is not. So here we're dividing. Okay, we're dividing, right? So when you have something like this, something with a lot of variables and it just looks nasty, I can just make each of these parts into its own fraction with these sections being the numerators and 4CDF as the denominator. So what I'm going to do is I'm going to put 20 c to the 4th, d squared f, which is this first section, okay, over 4CDF, which is our divisor, okay. Then I'm going to take this next section, minus 16CDF squared. I'm going to again put that over the divisor, 4CDF.
Clayton Wolford to the guidance office.
Then I'm going to take this last section, 4CDF, and put that in the numerator, and put it over our divisor, 4CDF. So I've broken this up into 3 separate fractions, so now I can cancel off within each fraction and get a simplified version. So 20 and 4. 4 goes into 20 5 times, so I'm going to cancel out the 4 and turn that 20 into a 5. Okay? I have 1 c on the bottom and 4 c's on top. So I'm going to cancel out that c on the bottom and take away 1 c on the top. So that c to the 4th becomes c to the 3rd. Okay? I have 1d on the bottom and 2d's on top. So I'm going to cancel out that 1d on the bottom and take away a d from the top. So that d squared just becomes a d. And then I have 1f on the bottom and 1f on top. So I can cancel those out completely. Then over here I have a 16 and a 4. 4 goes into 16 4 times. So I'm going to cancel out the 4, turn that 16 into a 4. All right. I have 1c on top, 1c on the bottom. So those can cancel out. I have 1d on the top, 1d on the bottom. So those can cancel out. I have 1f on the bottom and 2 f's on top. So I can cancel out the f on the bottom. And then I need to take away an f on top. So that f squared becomes f. Then over here, okay, so I have 4CDF being divided by 4CDF. If you have the same thing on the top and the bottom, you can just cancel them off completely and turn the whole fraction into 1. Okay, it's like taking 4 divided by 4. That's 1, right? X divided by x, that equals 1. Okay, so that's the same idea over here. So now let's just write what we have left. So in this fraction, on top I have a 5, a c to the 3rd, and a d. Okay. On the bottom, I had nothing. Good. So I really don't need this line. Okay. Over here, I don't have anything on the bottom, but on top I have a negative 4 and an f. And then this one, I just had that 1, so plus 1. Okay, so this is my simplified version. Okay. Again, one more time, what I did was I took this 4CDF and divided each of these parts separately. Okay. Crossed off what I could, and then I just wrote my simplified version down here. Awesome. All right, guys, one more. So just like this sign meant division, if you have something to the negative 1 power, that also means division. Okay, if you think back to our rules on the front, in that table, you put anything with a negative exponent down in the denominator, right? Which is where divisors go. So this all just means division. So what I'm going to do is I'm going to do the same thing I did over here by breaking it up into 3 fractions with this, except here I'm only going to have 2 fractions. This is fraction 1 and fraction 2. So my first fraction, I'm going to have 18x squared y on top over 3xy, my divisor. Then plus 27x cubed y squared z all over 3xy. All right. Now I can just start canceling out. So 3 goes into 18 6 times, so the 3 goes away and the 18 becomes a 6. I have 1x on the bottom and 2 x's on top. So I'm going to cancel out the x on the bottom and take away an x from the top. So turn the x squared just into an x. And I'm going to cancel out these y's completely. Then over here, 3 goes into 27 9 times. Okay. X and x cubed, right? So I can cancel off the x and take away an x from the top. So that x cubed becomes an x squared. I have 1 y on the bottom, y squared on top. So I'm going to cancel out the y on the bottom, turn that y squared into a y. And then I don't have anything to cancel the z out with, so I'm going to leave that z alone. So now let's just write what we have left. So I have a 6 left over here and an x. Okay, everything else has been canceled out. Plus, I have a 9, an x squared, a y, and a z. Okay, so this is my simplified version. All right. Okay, guys, so this video, as I've talked about to you, it's posted on my website. So please go back through, rewatch it, pause it, go back over your notes again. And also, please feel free to email me with any questions. I'll have my phone on me at all times while I'm gone. I know this is really inconvenient that I'm gone. But please rewatch this video, go back over your notes. Extra homework sheets are on my website, so please look at those. But please email me with any questions that you have. All right. Bye, guys.